we're not having class on Monday next week. Monday next week we will be off. So I wanted to talk a little bit about the Rubik's project. Because it has a wonderful example of relative moves. Okay, so this is the Rubik's project. And we go down to the end, toward the end. We talk about the Rubik's project, the actual Rubik's moving of the Rubik's cube. So this is the actual spinner, and there's 6 motors attached to it, and that is the object is to push a button on the screen of the computer, and it, from a random position, brings the cube back to its home position. So it's a non-trivial project. It has a lot of dips and dives in it. So basically, in this project, we want to be able to describe the moves that we need in order to do this. So the there's the wiring. And you're given a starter program, and the starter program basically is this screen, and then this screen plus the other 2 screens, which are down here, and this screen, and this screen. So basically, you're given a program that has 3 screens with it. And what you're supposed to do is, first of all, you're supposed to, from here, you have 2 drive motors. You have one drive for the 3 that are here, the white, green, and red, and you have 3 here for the blue, yellow, and orange. And you multiplex the signals to the 3 because you can only spin one at a time, and I only had 10 outputs, but you dedicate 2 outputs to the actual motor and 3 to the direction and 1 to the left or right. So basically you have 2 relative move instructions in your program to start out with. And this is just so that you can prove that it runs and to set up the motors. So basically you click on the enable. This is the enable. Well, no, you turn it on first. You turn it on, and then you click on this, which is the reset for the motor. So you basically turn this on, leave it on, click this, and it resets the motor. And then you can pick which one you want, and you can you can put a number in here for the speed and a number for the distance, and you say relative move, and it will move that amount. So that's what that does for you. Okay, and then here are those instructions. And that's all it is relative move. It's a relative move instruction. So basically what you're giving it is this distance at this velocity, and when you hit this with a one shot, it does the action. And when it's done, this bit over here turns on. And that's all it is. It's really simple. You have 2 axes, axis 1 and axis 2, and tell it which way to go, and it goes. If you put in a minus 100, it will go in the counterclockwise direction. If you put a positive 100, it'll go in the clockwise direction, and it will go, 100 is 90 degrees. So if you wanted to go 180 degrees, you'd put in 200. There is also a setup in this block for acceleration and deceleration, and I think that some of them should have set the deceleration a little bit slower, because every once in a while there's an overshoot. So if you want to keep it from overshooting, you basically slow it down as it's coming to an end. So basically what happens is it's like a lampshade. You go up, accelerate, then you go at a certain speed, and then you go down. And I think what they should do, you can accelerate pretty quick, but when you're ready to go down, you should do a little bit more of a slope like this instead of a little bit like that. But anyway, whether it's like this or like this, it's up to you. But that's what this is about. So the velocity is this velocity right here, and the distance is the total of the distance is everything underneath the curve. So this is part of the distance, this is part of the distance, this is part of the distance. Anyway, it's the integral of time times velocity. How's that? Anyway, so now I come down here and I say, okay, now here are these reset and power instructions and the move instruction. And I ask the question, well, first of all, how do you set up the array for the colors that are present? And this shows you how to set those up. And it's done for you. You start here and you fill in the array with the colors. And that fills in this array, the tiles array. And that's the bottom side. Now I say it's your turn. Okay, so now I advise you to look at an established solution and see if you can do that. Okay, so let's look at an established solution. All right, so here is, way down here is an established solution. How to solve the Rubik's Cube. This is out of the web. This is not mine, this is from the web. And it says, do the white cross, then the white corners, then the second layer, then the yellow cross, then the yellow edges, then the yellow corners. So you can start with the white cross. And the steps to getting the white cross, they talk about them right here. And you can click on that and it'll show you. And these are the white cross. This is this is the steps for the white cross. Okay. So I suggested that they do something like this, but when I first started out, I said, okay, you can just start and then code this in directly. So basically what some of the people did was that they took a stab at it and they got it to work, but it took forever, and it was I think probably the longest way that you could have done it. But anyway, they did it. But what they did was they looked at what it would take to do the white cross. If you go back up here and you look at it for a second, let's look at, okay, so here is the white side, the top side. And what you want to do with the white cross is you want to get the white and the green here, the white and the orange there, the white and the red there, and the white and the blue there. But let's say, for instance, that the white and the green was right over here. White and green was in 1 and 33. Would you ask that question? Is the white and the green, this is the white, this is the green, are they in tiles 1 and 33? So they're asking, are they there? And if they are, you set up a move instruction that basically says, move till you basically do what? You move 180 degrees. So you move this around to here so that you get the white and the green over here. Now you don't yet know whether or not the white is here and the green is here, or the white is here and the green is here. You don't know that, but you at least got it in the right spot. It may be upside down, but you at least got it in the right spot. So you execute a move statement. And this then does the movement of the tiles in the array to keep track of where the tiles are in the array. So this is your move statement, and this is that. Now, all that did was one move. It did this from here over to there, and that's all it did, 180 degrees from there to there. That's all it did. If it wasn't there, it would be someplace else, and you have to go find it. And this is all this is doing, detecting where it is. If it's in that spot, you do something. Now, it might mean more than one move. It might be just one move. This was just one move. But you might have, you see the 200 because it's a 180-degree move. It's a 200 there, and you turn it clockwise. And then you do 2 of the white turn. So you turn the white axis 180 degrees, 90 degrees and 90 degrees. So you basically do that. And that's all you did. Now, that is a very cumbersome and long way to write this, but note what you've got. You've got basically an explanation for just this position right here. Now you got to go to this position, you got to go on the back side, you got to go down here, you got to go over here, you got to go down on the bottom. And that's just to get you into this plane. And then once you get into this plane, how do you get it to the white up here and the green up here? That's the next step. But basically, the first step is to get it into this green plane. And notice how many moves that would take. How many relative moves is that? I don't know, but it's quite a few. It's quite a few of these. So in so doing, you can have, every time you have this kind of a statement, you've got the possibility of what? You've got a possibility of it can error out on you. And finding those errors and trying to fix them are problematic. Now, after each of those, then you want a little time delay to go to the next one. So there should have been a timer. There should have been a timer here as well. A time delay to then to move to the next command. So this is a pretty burdensome way of getting a project like this done. But it will work, and that's what actually happened with the first group that did it. It's just kind of like a one after the other of these to get the tiles over, and that's just one tile. That's just the white-green tile. So you've got to write the code to do every one of those possible moves. If the tile is there, you have to have a move statement for it. The other way to attack this problem is to say, I'm going to have like a recipe and only have one of these statements. And that's what I suggested afterward down here, which basically says what? After you think about it for a while and after you've written a little bit of code, you start thinking about easier ways of accomplishing the same thing. And if you can, you want to, okay? So what you do is you make these kinds of things variables. Like this and this, make it a variable. Make that a variable, make that a variable. Okay? And also, you only have one of these if you have a stack of commands. So basically make this a step where if this is to be executed, make this a variable and make this a variable, and then you come around and you do this, and you just keep doing the same thing again and again and again, but you only use it one time. So you don't just keep adding to these. Every one of these can have an error. And by the time you check every one of them out and get them right, you'll spend a lot of time as opposed to having this done once and in a step in a recipe. And that's my suggestion to those of you who are doing this kind of a project. Think to make sure that you only use these as you absolutely necessarily have to. And that's, I think, a smart way to address this kind of a problem. Don't put too many of these out there. Every one that you do, it can it can blow up on you, and they do. Okay, now that's kind of a off-the-wall piece of this course, but we're operating under the assumption that some of you are actually doing this, and I want you to get the idea that you can use a matrix type approach. Now, we already use a matrix for the tiles, but now we're also using a matrix to go down to actually execute these instructions. Okay, now this shows that going through a matrix, and that's all this is just going down through a matrix. That's all it's showing. Okay, but this would be a possible way of addressing the bits in the word. And then the next thing I suggested was that you take the information that was here and move it to an Excel spreadsheet. So basically, what you have is you have a bunch of cells in your Excel spreadsheet that basically have ones and zeros or pieces of information in them, like the information for this would maybe be this cell, and this would be another one, this would be another one. And all of these are either ones or zeros or a number, like whatever's supposed to go in these positions in the array. And then you put an equation here that basically is this number would be the sum of all of these times their bit number. In other words, the 0 to 3 would be times 1. This would be times 8. This would be times 1, 2, 4, 8, 16, 32, 64. So this number in here, tile 1 would be times 64. This one would be times whatever that bit would be. And that would be this block right here. And this one would be your total of all these. And then what you do is you copy paste this into your PLC, into your array, and you can use this as your array. So you don't have to build this information in your PLC. You can build it in your computer and then build your table from that. Okay? That's kind of a roundabout way of saying you're not cheating, but you're taking advantage of all the pieces of equipment that you have. You have Excel spreadsheet, you can copy paste from there into your array, et cetera, et cetera, et cetera. That's what that's about. So those of you who are interested in that, my suggestion. Okay, let's go back to chapter 17. I want to talk to you a little bit about some of these projects. And I hate to scare anybody and say, well, this is what he's going to ask or whatever. I don't know what I'm going to ask, but I certainly have asked in the past some of these questions, and I want you to be aware of them. So I'll give you a little bit of a heads up as to what I'm trying to get you to think about in terms of what you can do for not only your project. Now, at the end of this chapter, because we had real problems in sometimes in the past in getting this information accepted. So basically what I did was I wrote the program. So Lab 17.1 is written. Okay, it's written in its entirety. Now, what I wanted you to do in this example was to take the stepper motor and attach it to the PLC, which I show you how to wire. It's not hard to wire. And then spin it twice circularly, go around twice in the clockwise direction, dwell for a few seconds, and then spin it clockwise in the counterclockwise direction, times 2. So you spin it twice one way, dwell for a little bit, and spin it twice the other direction, and then you're done. Okay? So I call it move 1, then dwell, then move 2. Move forward, and move reverse. Now, in essence, what you can do, they have a table you can fill in, and it would do this, except that the table, you could not hit a halt button, and then it picked back up where it was at. So if you did a halt, you had to break it out from a table. You couldn't use a table. So if you did a halt statement, you had to write all of the move statements, and these are not relative moves, these are absolute moves. These are absolutes. You can do this with Alan Bradley too. This is an 8-point lab, and you can do it with Siemens. It's all given, okay? But here is the little things at the top where you can actually do the same kind of thing that I was doing in the toggling. So there's a base program given to you that has 6 statements in it, and basically you toggle the second button up, which basically turns on the power, and that button stays up. The next one is you toggle the reset button, which is the first button. That's the first one over here, and then you turn it up and then put it back down. Then you toggle the third button, or the third toggle switch, and that sets your home position. Wherever your home position is, that sets it as that is your home. And from that point on, this is the program that you can download. And from that point on, you are on your own. You can do a move velocity, you can do a move relative, or you can do a halt, and you can do a move absolute. Now, with the move velocity, it just says go. It doesn't ever stop. So if you want to stop, you have to execute a halt statement. A move relative moves a distance and stops on its own. So this one would move a distance and then stop. It would move that distance and it would stop. It would have that velocity and it would stop. All right? A move relative or a move absolute does the same thing. Now this command table, again, it is there, but it is not usable with the way that I state the program, because in the program I have a halt. And if you halt, this does not pick back up again. So you have to use a sequence of move statements. All right? So down here, I actually start, do an HMI program, and I write it out. It's all written out for you. There it is. And you can put it in and get it to work. It will work 100%. This is a given. It will work in manual. It'll work in auto. And there are the additional instructions for the actual state diagram. And it's done. Now you can do the same thing with the Allen Bradley, although I don't give you exactly the same thing, but I give you close to it. And you can copy and do the same thing with Allen Bradley. Some people have done the Allen Bradley as well as the Siemens. It's with a servo instead of a stepper. That's the only difference. The instructions look the same. The only difference really between Allen Bradley and Siemens, and there's a couple of differences, but not just one. But the main difference are that with Allen Bradley, every time you code a move statement, you have to add a tag, and it's just an additional thing you have to think about. But every time you put in another move statement, you have to increment the tag number to another tag. You can't use the same tag over again. So you have to declare a tag with it. And the difference between manual and auto in Allen Bradley is, I think one is auto, two is manual, but you have to read that one. I don't think it's not hard to do, but one is one and two is the other. I think it's one is auto. All right, so that kind of gives you a little bit of a flavor as to, and by the way, what's the answer to this question right here? What is a speed pattern? That's a lot of pulses. That's a fast stepper. What is this? That's a decelerating stepper. What is this? That's a slow stepper. And what is this? That is a medium step. It's a fast speed, a very slow speed, and a moderate speed of a stepper. And there's the decelerating one, okay? And again, some of these are pretty easy. I've tried some of these, and I've asked some of these on tests, and I've gotten varying results. Hard to ask good questions in this arena. There are very few of these that are easy to ask good questions are, and I struggle with asking good questions. Let's see if there are any other ones down here. A couple of the ones that I'll be blunt with you. If I ask you something, we will review it. How's that? I'm not going to just put something out there and not give you a heads up as to what I'm going to ask. So this is an area that is changing. My book is with the older version of the Siemens. I do not know about the newer version of the Allen Bradley. I do know the newer version of the Siemens has made this stuff really not totally obsolete, but they've now got synchronous motion control type applications that you can have synchronized motors that work together, and they do much more sophisticated problems than they used to. This is a problem that you may or may not consider a hard one, but it is, because why? Well, you want, that's kind of like a sheet of layer of plywood, like the layment of plywood, the little thin piece of wood that goes into plywood. And what has to happen is, as this gets smaller, this knife gets a little faster. So it starts out rather slow, moving in, and gradually, as you get closer to the middle, it speeds up. Not a lot, but it does speed up. So again, and it has to speed up based on the speed of this motor, and basically I don't know whether this is a, for sure, I don't know for sure whether this is a coordinated axis or not, but I would strongly suspect that it would be. Okay, does anybody have any questions about this chapter? The differences between Allen Bradley and Siemens in the area of motion control is very, very small. They both have relative move statements. They both have absolute move statements. They both have this move velocity statement. Another thing that they do is both of them have, looking here, the done bit is not this bit right up here, it's down here. The done bit for Allen Bradley is way down here, but it's not up here. You would expect it to be right there when it's done. Nope, that's not the done bit. That's the enable bit carried through. So when you have this bit, it goes over, it goes to there with Allen Bradley. With Siemens, when you're done, it comes out here. So in other words, you do the move, and when you're done with the move, then this bit turns on. And with Allen Bradley, it's down here, but it's the same thing. It does the exact same thing. So it's very similar. You can write the same program in each, and you get similar, very, very, very similar results. They're almost the same. Okay, enough on motors. Hopefully you got a little bit out of that. And like I said, if I do ask you a motors question, I will be very blunt with you. I don't know what I'm going to ask, but I do know that it can't be really sophisticated. But I'll give you here's some of the programming from the Allen Bradley. There's the Allen Bradley, and it looks pretty much the same. Um, this is motion type. I think that one is a 1 is absolute and 2 is relative. That's where the 1 and the 2 is. But you hit them with a one shot and it takes off and does it. And when it's done, PC, that's the last one there. It's part complete or action complete. The done bit is not the done bit. The done bit is just that it got it. This down here is the one when the action is complete that it turns on. Yeah, the done bit is not what you would normally think of the done bit as. Okay, enough on that. And then chapter 15, I want to go through a little bit of this. Now, the problem with chapter 15 is, like most things, it's a course in and of itself. And you might think that's an excuse, but it is not. Most projects have extensive use of HMI. Now, the problem with all that is that when you are bidding a project, you want to get the project, so you cut every corner you can, and the corners that they cut are in the HMI area. But when you go out and are demoing your equipment to somebody, you want to have the nicest HMI because that's what people look at. So when you are creating something and you're working on this project, and then at the end of the project, the vice presidents and the presidents and all the high rollers come in and they come in and they want to see something. What do they come and look at in your plants? They look at the HMI they look at the HMI screens. Believe it or not, that's what they look at. And they sit there and they ooh and ah at them, and you want to make them think that they've got a lot of bang for their buck. That's what they look at. They look at the HMI screens. So you want to have something that they can identify with, but you also want to have something that the operators can actually use. So you have the glitz, a little bit of glitz for the big guys, but you also want to have something that the operators can actually use. If there's anything that is an embarrassment in a plant, it is that somebody read something off of an HMI screen, decided the wrong thing, and it shut the plant down because they didn't have to. It's just something on an HMI screen. It's not real. It's just reporting on something, but yet that something can actually shut down the plant. That's happened. It happened at 3 Mile Island. It happened, I think, at Chernobyl. Most of the big nuclear plant faults that have occurred have been because an operator chose the wrong action, and he chose the wrong action because he was getting faulty information or he was getting too much information. Too much information is bad. You cannot get a person to think straight if they're bombarded with too much information. So if you throw everything at them, that's not a good system, okay? So we will talk a lot about SA in this chapter, situation awareness. And this is no just high-flying theory that doesn't have weight. This does have weight. Situation awareness is what you want to get to. Now, getting to situation awareness is not always easy. You have to think like a teacher and try to get across to the student, the operator, what you want them to understand. And this sometimes is not easy. They may be somebody that they've been there 30 years and they know the plant inside and out. They may have been there 3 days. You don't know. So you have to be able to figure out not whether they know something or not, but help them to get to the bottom of whatever the problem is, if there's a problem. Okay? Now we have 3 of these various programming packages here. We have RSView Me, we have the Studio, and we have WinCC. WinCC is the Siemens. Studio is the one that's on the with Studio 5000, and RSView is the old one that you can probably boot up in 2350. Okay, so this is all we have. Now this is another one that you could get access to, and there's another one that I would like to get access to, but I haven't done it for a number of reasons. It's a programming package called Ignition. And Ignition is the newest, latest, and greatest, and people like it, and I just have not had time to absorb it or anything like that. I do have 7 licenses for it. I could download it this summer and become a little bit more familiar with it, but I just haven't had time. But I've been told by people in the Toledo area that this is the one that they use. So if you're interested in HMI a lot and you want to get up to speed on this, I do have 7 licenses. I can give you one, okay? I'm not trying to give them away, but if you want one, as long as you're not doing it for profit, I can give it to you. All right? So, I want to go back and I want to show you what was done before we had an HMI screen. Everybody understand what HMI stands for, right? HMI, human, machine, interface. Now we're talking about what used to be over here on the right, and then what we have today is very different. This is what we used to have. Why is that not a good way to go? Well, because this process of doing this is a very cumbersome process, and it takes a long time, and it costs a lot of money. You have to get a design implemented. You have to come up with a picture of what you want to do. You have to draw it out. You have to draw the schematic of what you want. You have to get it out for bids. The bids have to go to panel shops. The panel shops have to bid it. Then they come back with their price and you negotiate with them. Then the purchasing agent gets the lowest of the 3 bids. Then they have to go out and buy the parts, put it together. They call you over. You go check it out at their panel shop. Then you sign off on it. Then it gets shipped to the plant, whatever the plant is. The plant then has to install it, or an electrician has to install it. So you have to have a drawing of how it gets installed. Then if there's any modifications to it, what has to happen? You have to drill holes. You have to rewire it. It's not fun. This is not a fun process to do this. Okay? Now, it's a long time to do all that, and it also is expensive. And for what? A bunch of buttons on a screen? That's really ridiculous. So how fast can you do something like this with an HMI? Believe it or not, the night before you're ready to start it up, you can do this. Okay? So the time element is huge. The cost element is also huge. But this is what we get stuck with many times. Now, with this emergency stop button, you cannot replace that. You have to have that button out there someplace. Other than that, all these buttons could have been replaced on a panel with the HMI screens. And you've all done HMI screens now, I think. Most of you have done 3 or 4 of them. And you see the potential for how that you could do this on a screen. This is not rocket science. You can do this. Okay? What is this? Looks like a typewriter without a keyboard, doesn't it? Or a printer. What is it? It's exactly what it is. It's a printer. It's an alarm printer. So basically, if you had alarms that you have to get out, you would print them out. The bad ones would be in red. The normal would be in black. What is this? These are in place in many power plants still today, and some other facilities as well, but basically power plants still standardize on this. This is a phenolic plastic mock-up of your process right there. And these are buttons that are hardwired buttons. If you want to make a change, you have to take the plastic off, take the rivets out, and put it in and change it again. It's a mess. I've done it. It is not fun. What is this? This is an alarm panel. All these little alarms in here have to be engraved. They have to be, like a little engraving tool, has to be printed to engrave all these names. Not fun. What is this? This would be like a strip chart, like an analog signal output. What's wrong with this? It's paper. So the pins can run out, the paper can run out, the pins can blot. All that can mess up your output. But on the other hand, these were used for a long time. Not anymore. What is this? This is a readout of a temperature. This is a thermocouple readout. What are these? These are PID controllers that you could put in, and they could be made to work, or you could have it on a screen of a computer, which is much more simplified, and you've already done. Okay, some of you have already done. What is this? A mess. The rule of thumb for anybody putting a panel together is this, and it's my rule of thumb, but it's the rule of thumb for anybody putting a panel together. If at the end of the job you can't get the covers back on the panduit, you failed. Okay, so if you can get the covers back on these and get all these wires tucked in, at least you have a chance to make it look like a decent project. But something like this, it'll never happen, and I hate to think about how to get this all straightened up and make it look halfway decent. I saw this picture and I thought, boy, I've been there, done that, and I've seen this kind of thing before many, many times, and I hate it. And usually I don't like to even admit that I ever had anything to do with anything like that, but I have. Anyway, what's this? It's a panel that I built. I didn't physically build it, but I had it built, and that was in 1980 dollars. That was $100,000. Anyway, built by a company called Panelmatic in Youngstown, Ohio, and somebody a couple years ago told me, said they're still in existence. They had worked for them that summer. So they made it from 1980 to 2025. They're still in the business. This went to Columbia, South Carolina. So you have all different types of HMIs. You little bigger and 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 bigger, more complicated. They even have HMIs that are on remote little keypads that you can take that are wireless. These are all wireless keypads. You can even get an HMI screen on your cell phone. In a lot of applications you can do that. So again, there's all different styles and types and all that kind of stuff. And I don't want to beat you up on that, but that's what it is. Now, with Allen Bradley, this is the newer one. This is the one that you probably are going to use. This is the look and feel of it if you pick the View. Okay? The View. And now, this is the steps that you have to take in order to get it to work, and I hope that you've done that. Not a biggie. Now, there's two versions of RS View, and there's two versions of Allen Bradley. Okay, I'll just be blunt. There's an ME version and an SE version. What's the difference between this? ME is a standalone. This is tied to a database. Okay. What's the difference? Well, if I have a panel out on the line and I have another panel someplace else out on the line and I have an alarm, it also pops up over here. Do I have to answer it in both places? If I have an ME, yes. I have to go over here and answer it, and I have to go over here and answer it. If I have a database that is behind these, the alarm is actually answered right there, and this one does not have to be answered. Does everybody see that? The database is stored someplace else in the computer, and you're all communicating together, and they're all communicating to the phone. Everything is to the good of the order. It's good to everybody because all your data is held back in some computer someplace. Not right here, or not right here, but it's held back here. So it's much more systematic, an SE or the SE version. Of course, they cost more, but they're worth it, okay? So the difference between a standalone and a database version is you answer the query at one spot and it takes care of it for every place. You can not have to worry about running around and doing something 10 different times or whatever, and it works, okay? Now, I made a big deal about this back in the day, and I don't make as much of a big deal about it as I used to. But Alan Bradley and other people had the same basic idea on how to handle, and I don't believe that Siemens does this the same way, but I'm not sure anymore. But I was shown this, and I thought, this has got to be the best thing ever since sliced bread. But if you have a button A and you have a coil A, does that ever work? And the answer is no. But if you tie this to an HMI panel and you use it in the multi-state mode, you can. For the simple reason that you can take the multi-state button and you hit it and it changes state, okay? So you hit it, it goes to a 1, you hit it and it goes to a 0. And it changes this bit right here, which also changes this bit right here, by the way. They both change at the same time. So this acts as a seal circuit. But note what you can do. You can put in things that can stop it if you want to. And you can also put in things that can be done in parallel with it, like this. Now, what does that mean? It means from the program or the HMI in auto or manual, I can start and stop something. Now that works, that little circuit works 100%. And if you don't believe that, you look at my programs that I wrote, the last programs that I wrote for a major project, and they all had this same look to them. Multi-state button works with this application. Now, I asked Siemens and I said, how do you do that? And you know the response? Kind of a smart aleck response, but it's true, and I've since thought about it. And their response was, you can do anything with programming, and you can. So basically, what you have to come up with is something that will do the same thing. You want to be able to, from the HMI or from the program, to be able to turn on and run something or turn it off, either from program mode or from the HMI. And that's basically what this does, the multi-state button. But again, now I wanted to tell you this, that it also gives you the ability to do it with one button. But I also now know that you can have layering of buttons in Siemens, and you can have it look like it one button when it's really three or four buttons, okay? So with Siemens and layering, you can do, and like I said, the guy from Siemens was kind of smart aleck about it, but he said it right. He said you can do anything with programming. So you can create this will show you, what this thing right here will show you the state of A. It will show you whether it's running or it's stopped. And if you want to change it, you can, unless it's under program control. If the program's dominating it, if it's holding it one way or another, it'll tell you. But if you can change it from the screen, and it also shows you the state of it. Now, what would you have had to have done before? 3 buttons: the start, the stop, and the run button. Now, honest to goodness, in one era, back 20 years ago or so, this was the way that you did this. And I think they've gotten to the point where a lot of people have done it a lot of different ways. And you don't have to do it this way. But you can do all of this in one button. Okay? You do not need 3. So whether you do it this way or you do it Siemens way, I don't care. But believe me, if you're putting things on a screen, isn't it better to have one button do all of it than have 3 or 4 buttons to clutter up your screen? It is. So as you're working through this kind of application, realize that it's better to have 1 than 3. Okay, so we've covered what SE and ME do as the difference. We've also covered a little bit about some of Now, this is the old factory RS view, and this is the older version, and it shows you how, and it does it on the videos as well, how to log in and how to get this started. It's a rather cryptic way of getting it started, but it does get you started. If you want to run just this screen, you run the little diamond or the little triangle right here. If you want to run the whole application, you run the little man. One of the weirdest things in the world is you click on the little man. And right there. Okay, this runs just this screen. You want to run your whole application, run it there. So again, this is old. I'm not trying to convince you this is the best. It's just the older version. Some people are still using it. Some people are flipping over and using RS, the view. Some people are using Ignition. Ignition is a third party. Everybody understand the third party? They're not one of the majors. They're a third party. But they're catching on and people are using it. They like it, so they're using it. This is a older version, been around for 30 years. People are still using it. There's the little man. There's the triangle. There's some of the buttons with Siemens. Again, you've already worked at this. You already know some of this stuff. This is not new. One of the things at one time, I had this chapter to kind of, back here, but as time moved forward, I put more and more of this stuff in the earlier chapters because I think you should be able to do this stuff earlier. And this is an application that if you do in this chapter, you can. This is one of the applications that is a 2-pointer, but you can have this bottle moving across the screen and then populating one of these spots in the case. And it's very easy to do. You can do it with Allen Bradley or Siemens, either one. The moving of the bottle is something that you generate with a moving number. You physically have to have a number that changes state. It has to move from 1 to some high number. It's an integer. The integer is usually a number tied to a timer. So you have a timer that resets itself. And the accumulated value is what you use to move the bottle from the low position to the high position. As the number gets bigger, you tie the number and the timer, the accumulated value, to the movement of the bottle across the conveyor. And it works. Now, all that being said, that and then the visibility or invisibility of the bottles in the case is nice, but it does not add to your ability to understand the process. So this is called animation, but animation in and of itself is not helpful. It's cute, but it doesn't necessarily help you. So running a bottle across the screen might really give the ooh-ah factor to a boss or somebody in a management, but to an operator, it doesn't mean a lot. Be careful how you do this. Okay, so now we get into the idea of, and again, this goes back and we go through all these steps here again for getting your automation working. But I get into another area, which is basically that of looking at how processes are set up. It's the same conveyor problem. Configuring the bottle movement with Allen Bradley. Now, in their newer, the View, they do not have the ability to animate using a number the movement of a bottle. They use states, which I think really is not good. But anyway, they do. The older one shows the movement across. So they do it, but not with the new one. And I know what they would say if you say, well, you don't do animation with movements and all that kind of stuff. They'd say, well, you can use the old one, that'll work. And it does. We don't believe in animation just to be animating anymore. That's what they'll probably say. I don't know. So there's building of the case from Allen Bradley point of view. And again, they'll put the bottles in each of these spots, but they'll make them invisible if the count isn't a certain count. And they use the ability of a counter to make them visible or invisible. So they draw the same picture again and again and again, and they populate each of the spots with that, and then they make it visible or invisible based on the count. You can do that. You can read through this and you can make those happen, and those are good. There is 2-point labs, but you can do that. They're kind of fun. Now we get down here, and this gets a little bit more meaningful. These are labs that were done by one of the students here, but this gets into a whole different area, and this is a guy by the name of Bill Holofield. And I apologized to him once I got a hold of his white paper. He did a white paper, which basically is his book, and I just dumped it in, and he took great offense at that. I told him, I said I gave him credit for it, but he didn't like it, so I did take everything out except his points, his major points. I gave him credit for it. So, situation awareness, what is it? It can mean different things to different applications. These guys are, this group here that did this book did the gas lines, the big gas lines that came around the city of Toledo. I don't know where they came from, but they actually did. They never visited us or whatever, but they actually worked on the gas lines that went around Toledo recently, about 4 years ago. There's a big series of gas lines that went around, and they were burying them out in the boonies out by Waterville. And I don't know exactly where all they went, but they were working on those from a point of view of the HMI screens that went along with it. So they have some books, the High Performance HMI Handbook, which I have a copy of. If you ever want to look at it, you can look at it. Designing for situation awareness. But again, the people that are doing this are gas transportation specialists. So they're thinking in terms of getting a highly explosive something from point A to point B. And they're very much aware of the criteria of that. Other people aren't. Other people are looking at other things, and they could care less about what transportation of methane gas. They don't care. But they do have a lot of very good points, okay? Now this is a picture of, in the 1980s, what a graphics panel looked like. Before you had HMI, this would be the way that you would see a screen. And then they moved to something like this. Now what does this look like? First of all, it's white on black instead of black on white. What's wrong with that? White on black is hard to read, and it washes out. Why would anybody ever use that? Because that was the standard for some of the big companies back in the 80s, okay? Babcock-Wilcox, this was their standard. So if you wanted to use the Babcock-Wilcox standard, you used white on black instead of black on white. What else is wrong with this? It's a picture with a lot of buttons and a lot of things, but it doesn't tell you very much. And if these lights all start blinking at you at the same time, what happens? The operator doesn't have a prayer of knowing which one to answer, okay? So this looks like what? It looks like the dumping of a P and ID into the graphics. So basically, this is a no-no, but a lot of people do it. You just dump the P and ID into graphic form. And you got it. That's the cheapest way of getting a graphic that people can say, now that's what you want. Now, the only problem with that is what? You're going against the situation awareness people. But it's hard to define situation awareness until you've seen it and you've done it for a while, and then all of a sudden you get smart. But this is not situation awareness. This is over flooding this is a flooding of the zone with information, and it's not what you would want. Now, if they say they've got to have this, then you could put this in, but you also need to take this information to another screen. Now, one of the nice things about his Bill Holofield, and he doesn't really tell you exactly how to do it, but you can, oh, and by the way, this is another one. Now, what does this do? From here to here, what does this do? It jazzed it up, didn't it? So this is a P and ID with 3D. And what does 3D do for you? The situation awareness guys say it's actually a distraction. Anything that's a distraction should be removed. So don't do 3D, according to them. Again, this is something that you will find different people that will say different things. And this is one of those times when you look at the ISA standard and you could drive a truck through it. They say, make it situation awareness, and then some of their example programs that they show that are good examples are stuff like this. And then the guys from situation awareness say that 3D is bad. So again, you have to find out for yourself what your opinion is on this, but I tend to agree with them that the 3D does not enhance. Okay? What is this? The world's best HMI. Why does this have to be the world's best HMI? Because you're training pilots to fly. And if you don't get it right, what happens? People die. So this is bring it down to the nitty-gritty. Here's a P and ID. And then this is the same P and ID without all the lines. Now, the question that you've got to ask is this better or is this better? You have to make up your own mind on that. They're the same. Can you believe this and this are the same thing? They are. Which would you pick? How many of you would say that you would rather put this on the screen than this? Again, I'm not going to ask you this on a test. How many of you would have this on the screen over this? How many of you would have this over this? Which way is better? I tend to agree with them. This is better. Okay? This is preferred. Why? Because everything you need to know is here. You don't know spit here. Okay? Maybe you don't agree with that. Maybe you've been taught by somebody that says, put that P and ID up there and make it look that way and make it 3D if you can and make it automated and have little guys running across the screen and all that kind of stuff. And you're going exactly against the situation awareness guys. But I'm telling you that there is a rationale for what they're saying. Again, not going to be a test question on a test, but it will be something that you might actually have to deal with. One more thought about this, and we're going to have to pack it in tonight. But I was working on a project quite a few years ago now, 1999, in which there were 4 people, 2 PLCs, and 4 people. I did the control, and somebody else did the HMI for the furnace combustion. And somebody else did the control, and somebody else did the HMI for the actual running of the reheat furnace. This is a steel reheat furnace. And who had the hardest job? This guy right here. Why? Because he was writing the rules for letting the pieces of steel in. And you can take behind a button or in a screen, you can write scripts. You can write a lot of scripts, and basically all the rules for either allowing or not allowing pieces of steel to come into that furnace were written right here. And they were bad. I mean, it was like, if you've had a course in heat transfer and making steel hardening of steel, you had to include all of that into the logic for this, and that's where it all landed. That guy it took him forever to get all that stuff done. My part was pretty good. I did it pretty quickly. This was written in India and brought over. So that was my first experience with having somebody working on the other half in someplace way far away. But anyway, every night it would come over, we would get a new update, and I would update to him and whatever, and that was it. But that was how that was done. This was done in Toronto. This was done in Toledo. And we put it all together, and it went to Sault Ste. Marie, Canada. Hey. Anyway, it can be done. You can work on stuff, and somebody else can be working on something someplace else, and it can be put together and made to work. But situation awareness is something that will hit you, and it will be something that you may or may not grasp fully until you're well into the project, and it may be too late. You might have to redo things or whatever. But I've got a lot more to talk about on this subject, but don't discount situation awareness, because it is something that you will have to deal with. And we've already talked about it a little bit. I want you to understand that I'm not an expert at this, but it will make you or break you in many cases with your project. A good graphic will help you. A bad graphic it might cripple you. So anyway, anybody have any questions, any thoughts? Thank you for your attention. See you on Wednesday. Take care.